Linear algebra. Matrices.
So linear algebra, important topics. Linear algebra is very easy and high scoring topic, so don't omit anything. And matrices and determinants itself, minimum we can expect 6 number of questions. Then linear transformation, matrix representation of linear transformation, and then rank nullity theorem, very important. The minimal polynomial, Jordan canonical form, and inner product spaces, orthonormal basis. These are all important topics in linear algebra. Every square matrix satisfies its characteristic equation or secular equation. This is known as the Cayley-Hamilton theorem. Sum and product of the eigenvalues of the matrix A equal to 11 minus 4 minus 7, 7 minus 2 minus 5, 10 minus 4 minus 6. These are all given. The sum and the product of the eigenvalues. So sum of the eigenvalues is nothing but sum of the diagonal entries. So 11 minus 2 minus 6. So 11 minus 8, 3. Maybe this may be correct, or here also we have 3. So single correct answer we have to find out. These two are incorrect. We can eliminate. And then product of the eigenvalues. Product of the eigenvalues is nothing but determinant of A. Product of the eigenvalues is determinant of A. See here, I give a shortcut. Instead of finding out the determinant, add first 3 elements, actually column wise 3, you get 0. 11 minus 4 minus 7, 0. And then second also you get 0. Add these 3 numbers, 7 minus 2 minus 5, 0. Third also 0. Sum of each row is 0, then 0 must be an eigenvalue of the matrix. So 0 is one of the eigenvalues, means determinant of A equal to product of the eigenvalues. So 0 into sum 0. So product of the eigenvalues is 0. So here minus 3. So this is eliminated. So only this is correct. The eigenvalues of, so all the entries are 1, 3 cross 3 matrix R. So directly the determinant of this matrix is 0. So 0 must be one of the eigenvalue. So we can eliminate this immediately. And what about other options? If all the entries are 1, the order must be one of the eigenvalue. So using this itself, you can find out the answer. So this is the answer. So remaining two eigenvalues are 0, 0. You can check determinant is 0. So product of the eigenvalues 0 into 0 into 3 equal to 0. And trace means this sum of the diagonal elements or sum of the eigenvalues. Here also 3, here also 3. You can verify this. So that's all. This is the answer. The matrix A is invertible, then for all B. So see this, for all B, not for particular B. For all B, which of the options are correct? If you take this one, determinant of A inverse B, it can be written as determinant of A into determinant of A inverse into determinant of B. Determinant of A and determinant of A inverse can be cancelled, because determinant of A inverse is nothing but 1 by determinant of A. So this answer and this answer cancelled. For the first option we get determinant of B. But determinant of B need not be 0 always. Only the determinant 0. Singular matrix means determinant 0. So otherwise determinant may be non-zero. So this is incorrect. And then second one, you can find out A inverse is nothing but I. So what is determinant of I? 1. So this option is correct. And the last one, third one, determinant of A inverse not equal to determinant of B. But we can show that equal to determinant of B. Suppose I take B equal to I. So A inverse become I. This side determinant will be 1, because determinant of I is 1. B equal to I means here also determinant 1. So they will be equal. So 1 equal to 1 will come. So this option is incorrect. So 1 equal to 1 we can get, but here it is given not equal to. So this option is incorrect. This one I already should put here. So determinant of A inverse equal to determinant of B always. This option is always true. So part C question answers B and D. The diagonal entries of a skew symmetric matrix R. So what is a skew symmetric matrix? A equal to minus A transpose. That is the definition for skew symmetric matrix. This is matrix wise. Element wise, Aij equal to minus Aji. So this is the definition for minus AJI. Here question is asked about diagonal entries. So diagonal entries AII equal to minus AII. So AII equal to minus AII. So take this minus AII this side, it will become plus AI. So twice AII equal to 0. So take this to right hand side. So you will get AII equal to 0. AII means diagonal entry. So for skew symmetric matrix, diagonal entries are always 0. This is the answer. The dimension of the vector space of all 6 cross 6 real symmetric matrices over R. This is first question. So what about this? So direct formula is summation n. Dimension of the vector space of all n by n symmetric matrices is summation n. So summation n is nothing but n into n plus 1 by 2. Here instead of n substitute 6. So we get 6 into 7 divided by 2. To simplify this, 3 2s are 6. So 3 into 7, 21. For the first one, 21 is the answer. And then second one, skew symmetric. So skew symmetric means summation n minus 1. So keep it in mind. Dimension of vector space of all n by n skew symmetric matrices is summation n minus 1. So summation n minus 1. Summation n minus 1. Put bracket like this. Reduce 1. That is the meaning. So summation n minus 1 is nothing but n minus 1 into n divided by 2. Here n equal to 6. So substitute. So n minus 1 is 5. So 5 into 6 divided by 2. So cancel this. 3 2s are 6. So 5 into 3, 15. For skew symmetric matrices, answer is 15. So for what value of k the system of equations is consistent? You have to find out the value of k. For this, write this matrix in echelon form. Echelon form means we know here 2 zeros and here 1 0. And for this item you have to find out, you will get like this. Here one element, here one element, here one element. Like this you will get. Here one element. Here 0 will come here, you work out. So this place what will come means k minus 10 will come. K minus 10. So consistent means it has solution. That is the meaning. Consistent means it has solution. Suppose this place is non-zero means rank of A is 2 because here all the 3 elements are 0, 3 entries are 0. So rank of A 2. For the system to have solution, this place must be 0. So k minus 10 equal to 0. So which implies k equal to 10. So 10 is the answer. K equal to 10. Given n by n matrix B defined by e power b defined by e power b equal to summation b power j by j factorial. This is nothing but definition of e power x. This is in matrix expansion. Let p be the characteristic polynomial of b. Then the matrix e power p of b is identity matrix, 0 matrix, e into identity matrix, pi into identity matrix. See, given p is a characteristic polynomial of b. So by Cayley-Hamilton theorem, every square matrix satisfies its characteristic polynomial. So p of b will be 0, 0 matrix. So this is the result. For any square matrix A, e power a can be written as like this. And then if A is a 0 matrix of order n, then e power a equal to I e power 0, that is equal to I, not 1. So matrix of e power p of b equal to e power 0, that is equal to I. So this is asked in June 2016 part B. December 2012 question. Let f of x be the minimal polynomial of the 4 by 4 matrix A equal to. Then the rank of the 4 by 4 matrix f of A is 0, 1, 2, 4. By Cayley-Hamilton theorem, every square matrix satisfies characteristic polynomial. Also, every matrix satisfies its minimal polynomial. So, f of a will be 0 matrix. So, rank of the 0 matrix is 0. So, rank of f of a 0. Option A is correct. Question from determinant. Let D1 equal to determinant of this matrix and D2 equal to determinant of minus x like that given. Then, so which of the following is true? So, simple calculation. See here. So, I start with D2. D2 equal to determinant of this matrix. So, now we know that determinant of A equal to determinant of A transpose. So, this matrix convert into its transpose. Interchange rows into columns. First row minus x A minus B is written here. Minus x A minus B. Likewise, second row into second column, third row into third column. And then R1 and R2, interchange R1 and R2 from this one. When you interchange, the determinant of the sign will be changed. So, put minus here, and then after that take this minus to the first row. Take this minus and multiply with the first row. So, this will become, so plus A will become minus A, and then plus B plus C. So, that is equal to again. So, from the first column take minus outside. This will become minus determinant of this matrix. So, this is nothing but D1. So, minus D1. See the option, we don't have D2 equal to minus D1. So, take minus another side. So, D1 equal to minus D2, that is in option C. So, this is the correct answer. You can see here. Let J denote the matrix of order n by n with all entries 1, and let B be a 3n by 3n matrix given by B equal to 0 0 j 0 j 0 j 0 0. Then the rank of B is, so this matrix B is asked here. Suppose we take n equal to 1, then J will become, J is given here, J denote the matrix order n by n with all entries 1. N equal to 1 means J will become single element matrix. So, this will become like this. Then from this substitute this one. So, instead of J we can put 1. So, this matrix B matrix will become like this. Clearly the rank of this matrix is 3. So, this is given here. So, this is the answer. This question is from properties of trace. Let A, P, B, n by n matrices, which of the following equals trace of A square B square. So, these 4 options are given. So, trace of A square B square equal to which trace? So, we know that trace of AB equal to trace of BA. That means you can interchange trace of AB equal to trace of BA. So, trace of A square B square. This A square B square can be written like this. A square is AA and B square is BB. And then put bracket for this second, starting from second A. So, A, B, B. So, consider this as one matrix and this as one matrix. So, A, this matrix equal to, interchange these two. So, this will become A, B, B, A. So, A, B, B, A. So, remove this bracket. So, this will look like a bar. Then, so remove this bracket, A, B, B, A. So, B into B is B square. So, trace of A, B square, A. Solution is B. Let S equal to the set of all matrices A such that A equal to collection of 5 cross 5 matrices. Aij equal to 0 or 1. That means only entries are either 0 or 1. Summation Aij equal to 1. That is row sum equal to 1 and column sum equal to 1. Then the number of elements in S. The question is, how many matrices are there satisfying these conditions? The entries must be either 0 or 1. Each row sum must be 1 and each column sum must be 1. So, see here, consider like this, like identity matrix. Suppose I put 1 here means to put 1 in the first row, I have 5 choices because I can put in any place. This 1 can be here or here or here or here or here. So to fill up the first row, I have 5 choices. And then second row, suppose I put 1 here. When I come to the second row, I cannot put 1 in this place because already 1 is there. Then the columns will become 2. So this must be 0. To fill up the second row, I have 4 choices to put 1. So 4. So like this, for third row 3 choices, fourth row 2 choices. When we come to the fifth row, already there will be 1 1 1 for each column. So there is no other choice. I should put 1 in this place only. So 1 choice. So total number of ways equal to 5 into 4 into 3 into 2 into 1, that is equal to 5 factorial ways. So there are 5 factorial elements in the set. Answer C. A not equal to identity matrix B and n by n matrix such that A square equal to A. It satisfies A square equal to A where in is the identity matrix. Which of the following statements is false? This is important. Suppose you don't know about all other things, so try from the given. So it is given that A square equal to A. So therefore the matrix satisfies the polynomial x square minus x equal to 0. So simplify this, x into x minus 1 equal to 0. So x equal to 0 and 1. So one of the eigenvalues must be 0. So the option D is false because in option D it is given the eigenvalues of A are each equal to 1. So this is part B question. So only one answer. So this statement is false. Let A be n by n matrices such that BA plus B square equal to I minus BA square, where I is the identity matrix. Which of the following is always true? So A is non-singular, B is non-singular, A plus B is non-singular, AB is non-singular. Part B question. So given BA plus B square equal to I minus BA square. So take this minus BA square this side. So this will become plus BA square. Take B outside in each term from each term. So B into A plus B plus A square equal to I. So B into some matrix equal to I. Therefore inverse of B exists. So B is non-singular always. The answer is option B. Let A be a 5 cross 5 matrix with the real entries such that the sum of the entries in each row of A is 1. Then sum of all the entries in A cube is 3, 15, 5, 125. Part B question. So this type of question you can take some examples. Take A equal to I5. Identity matrix order 5. Then A square will be I. A cube also 5. I5. So the sum of all the entries in A cube equal to 5 because it is a 5 cross 5 matrix. Diagonal alone contain 1 1 1 5 ones. Remaining all place will be 0. So sum of all the entries equal to 5. So the answer is option C. Let A be n by n real matrices. Which of the following statements is correct? Part B question. This is a direct question by Sylvester's rank inequality. Rank of A plus B less than or equal to rank of A plus rank of B. So option B. The determinant of the n by n permutation matrix. Actually usually identity matrix means main diagonal elements 1, all other places are 0. This is other diagonal contains 1, remaining places are 0. So what is the determinant of this matrix? There are two methods. One is this one. So number of exchanges of rows required for making this matrix identity matrix equal to n by 2. This bracket is, so x means the greatest integer less than or equal to x. For example 1.9 means 1 or 2, like that. That is the meaning. 1.9 is 1, 1.1 also 1. So x means greatest integer function. X means the greatest integer less than or equal to x. The determinant of this matrix is minus 1 power n by 2. This is one method. And another one is formula method. That is, consider like this. take the diagonal entries are alpha, alpha, alpha like that. Main diagonal entries are alpha, and other diagonal elements are beta like this. Other diagonal beta. Remaining places will be 0. Then determinant of this matrix equal to alpha square minus beta square the whole power n by 2. This is when the order of the matrix is even. So alpha square minus beta square power n by 2. So you can put like this, power n by 2. So in the given matrix alpha is 0 because here no element is given, means this place 0 0 0, and beta is 1. So substitute here, alpha is 0 and beta is 1. So 0 minus 1 square, we get 1 only, power n by 2. So we get the answer minus 1 power n by 2. This n by 2 also greatest integer value. So minus n by minus 1 power n by 2. So this is the answer. This is in solution B.